Hi, in this video, we want to look at the multiplication of vectors. In previous video, we looked at the concept of vectors, where we looked at the meaning of vectors, the need to study vectors as far as physics is concerned. We also looked at the addition and subtraction of vectors, where we talked about three different principles: the triangle law of addition of vectors, the parallelogram law of addition of vectors, and also the resolution of vectors into its various components. We use these three principles to solve questions on how to add vectors and subtract vectors. And also, we talked about the first part of the multiplication of vectors, where we looked at what it means to carry out dot products on two vectors. In this video, we'll be concluding our series on vectors, where we look at the vector multiplication or cross products. So let's say we have two vectors, A vector, and then I decided to split this into its various components, the AXI, AYJ, AZK, and then I have vector B, BXI plus BYJ plus BZK. Like we said in the previous video, when we multiply two vectors together and then we want our results to be a vector, not a scalar, not a number. In type of vector multiplication, or the type of multiplication we want to carry out is vector multiplication or the cross product. Because A multiplied by B will give another vector entirely. So we can say A vector, when we cross it, or when we do the cross product with B vector, then it must give another vector. So let's call that vector our C vector. Now, like we said, in order to carry out multiplication, the two vectors must be starting from the same point. But this time around, instead of applying our cosine theta, we are going to be applying our sine of theta. So why are we saying that? Imagine I were to have vector A like this. This is vector A. Okay. And then I have vector B moving in this direction. Okay. So this is vector B. Now, in order to carry out cross product, of course, there's an angle between these two, what's it called? There's an angle between these two vectors, A and B. So let's call that angle theta. In order to carry out cross products, I have to complete the parallelogram. Complete the parallelogram, that is, this will also be A. Let me draw that accurately. Okay, so this should be A, and then this should be all right. So when we complete our parallelogram, then we can say the area of this parallelogram will be our cross product. I'll repeat myself. When we want to carry out cross products, one way to carry out our cross products is if you know the angle between the two vectors A and B, for instance, we complete the parallelogram and then simplifying the area of the parallelogram. The area of the parallelogram is simply given by A times H, and then you find the cross product of these two vectors. But what if we're not given the angle between them? How then do we carry out our cross products? Then we want to use our determinant method. Okay, so before I write that, why do we say if we calculate the area of a parallelogram, then definitely we're taking our cross product. For dot product, we said we know the magnitude of A, we know the projection of B on A, and then we know the angle between them. So we take the cosine, the projection, of course, is the x-axis. Now for this, A cross B will simply be magnitude of A, magnitude of B, and then sine of the angle between them. Remember, if you go back to this parallelogram, the area is simply the base multiplied by the height. So if this is the height, from this point to this point is the height. What happens when I shift this height to this point? Sorry, let me do that properly. So what happens when I shift the height, let's say to this point? This looks like the projection of B. This time around, instead of being parallel, it is now perpendicular. And if I were to write this, I would simply say B sine theta. So that's why we are saying, if we know the magnitude of A, we know the magnitude of B, and then we know the angle between them, then we can simply say AB sine theta or A times H, because H is the same thing as saying B sine theta. But if we don't know any of this, and then we want to go the long method, then we have to use our determinant method, where we write this. So A cross B vector will simply be equal to, so draw our determinants. So this is I, this is J, this is K. Come down here. So this is AX, this is AY, this is AZ, this is BX, this is BY, this is BZ. So what we do to find I, J, and K, remember, if A has AXI, AYJ, AZK, and B has BXI, BYJ, BZK, then definitely C must have the I, J, and the K part. Now, how do we find I, J, and K? So let me clear this part of the screen, and then we can write that here. Okay. All right. So in order to find I, we simply block the first row and then the first column. That is, I want to block everything I can see here because I'm looking for I now. To block everything here, the first row, and block the first column too. Then the only thing I'll be left to see will be AY, AZ, BY, and BZ. I want to multiply the leading diagonal and subtract it from the backward diagonal. So I will simply, so you can do a parenthesis in front, will simply be AY dot BZ minus AZ dot BY. And that's how I find my I. Now, for this J has a negative symbol because of its cofactors. If you've not done matrices, then I suggest that you quickly take a book on matrices and try and catch up. Or you can check my channel. I'm going to be releasing a video on matrices very soon. But know that for matrices, when we want to find the determinants, the first number, the first member of my matrix has a positive cofactor. The second one, negative. The third one, positive. And then it goes like that till it reaches the end. So I is positive originally. J is negative originally. So this becomes negative J. Then do your box. Again, I'm going to be blocking the first row now and then the second column. So anywhere J appears in, I want to block it. So what am I left with? AX, BZ. So multiply the leading diagonal. Again, AX, BZ. Then subtract it from the backward diagonal. AZ, BX. AZ, BX. Then close the parenthesis. And come to the last one, plus K. And do your parenthesis. So K, block the third column, block the first row. So what am I left with? AX, BY, AY, BX. So apply the leading diagonal, AX, BY, then subtract it from the backward diagonal, that is AY, BX. So, and then we get our I, J, K component of our C vector. In order to find the magnitude of C vector, So the magnitude of C vector, C vector magnitude will simply be the CXI squared C plus CYJ squared plus CZK squared, and then we'll find the magnitude. To find the direction, then definitely we need to use something called the right hand rule. So that one we're not going to be covering it here because of limited resources. But it's quite easy for you to grasp. Peradventure, you are given a question and then you are asked to find the angle between two vectors. You can use a similar approach to that of the dot product. Know the magnitude of the first vector, know the magnitude of the second vector, then divide it from the product of both components that are like, just like we did in the previous video. So let's quickly move to solving a question on this so that we can be sure we've learned something. All right, so in order for us to find A cross B in this given question, we're told that A vector is given as 3i plus 2j minus k, and B vector is given as I minus 4j plus 5k. So we have to find A cross B. So like you said, A cross B vector will simply be equal to, so we do our determinant symbol, we write the I, j, and k on top of it. Then ax will be 3, ay will be 2, az minus 1, bx, that's 1, by minus 4, bz 5. So how do I know it is 3, 2, and 1? So just the number in front of I, the number in front of j, the number in front of k. For k, there's no number there, so we know it has a coefficient of 1, and the 1 is negative. Now, what do I do to find I, j, and k? So for I will simply bring out I. Remember, we said I has a positive sign, which is cofactor. J has a negative sign, which is cofactor. K has a positive sign, which is cofactor. So bring out I, then open the parentheses, then block the first row, block the first column. So I'm left with 2 minus 1, minus 4, and 5. So I want to multiply these two together and subtract it from these two. So that will give us 2 times 5. So 2 times 5. Okay, so let's not do something like this. So in order not to make this thing extremely lengthy, so 2 times 5 will simply give us 10. Then minus 4 times minus 1, so that's plus 4. So this is minus 4. Then we have this, so minus j. Okay, so j is again block the first row, block the second column. So 3 and 5. So open a bracket. This is 15. 1 times minus 1. So this is minus 1. So you can just say plus 1 here. Okay, and then for k plus k. Again, block the first row, block the third column. So I'm left with 3 minus 4, 2 and 1. So this is 3 times minus 4, that's minus 12. So minus 2 times 1, so that's minus 2. And then finally, we have 10 minus 4, so that's 6i. 15 plus 1, that's 16, minus 16j. Then minus 12 minus 2, so that's minus 14k. So this is our C vector. Now you might also be asked to find the magnitude of C. You might also be asked to find the magnitude of C. So magnitude of C magnitude be equal to the square root 6 squared plus 16 squared plus 14 squared. So let's take our calculator outside for this. So what is 6 squared? That's 36. Okay. So 6 squared plus 16 squared plus 14 squared. So our final answer is equal to 2 root 122. So this is the magnitude of our C vector. So this is how we do cross products as far as vector is concerned. So if you are being asked to find the angle between them, you just use the principle on dot products. Otherwise, basically the angle is always perpendicular. So either it is coming out of it or going inside of it. So this is all we have on vectors. Remember, we've talked about vectors extensively. If there's any parts that you feel what's it called, it's not quite clear, you can drop a comment in the description box. I'll go white, and then if it's to release another additional content for that, I'll do so. So feel free to always share this to your loved ones, your siblings, your colleagues, and then tell them to like the video and also subscribe, so that when I release more content like this, you'll be the first person to know about it. Thank you very much. Bye bye, and stay safe.